Ladies and gentlemen, welcome back to Mr. Lee Physics class. So today we are going to learn about the electromagnetic induction. Ladies and gentlemen, let's look at the diagram. The diagram, the left diagram show that the photo of a big dam. So the dam is used to generate the electric by using the flow of the water. So this means it's a hydroelectric power station. So right side show the inside a hydropower plants. So the structure of the internal structure, how the turbine is turned, the generator to produce the electric by using the flow of the water. Next slide show that there is how the generator is turning to produce the current. So we have two types of the generator. As long as the first, this means that we look at here, we have the magnet and the turbine is turning. So turbine is turning cause the magnetic flux change and generate the electric. Here show that the other type of turbine, we have curved turbine and also the runner turbine. This one mostly for the hydro power plants. And the size of the generator, we can compare to a human, the size of the human and the size of the generator. Next, a very famous scientist called Michael Faraday. Michael Faraday is a British physicist and chemist best known for his discoveries of electromagnetic induction and of the law of electrolysis. His biggest breakthrough in electricity was his invention of the electric motor. Okay? So that means that the motor and generator actually with the same structure. So when the coin is turning in the magnetic field, so it generates electric current to allow to light up the bulb. Ladies and gentlemen, in this lesson, you will learn to define the magnetic flux linkage, and the unit Weber. Objective 2, state and use the Faraday's law. And objective 3, state and use the Lenz's law. Now, let's look at the magnetic field. Magnetic field line represented by the red color arrow. So A will be the area of the coin. For example, the direction of the surface of the area is in this direction. Okay, so this means that now they are parallel. The surface are parallel to the magnetic flux density. So as a result, we said that magnetic flux is equal, is equal to B times with A. The unit will be Tesla. What is the meaning of Tesla? Tesla means that 1 Tesla means that 1 Weber, that means the unit for the magnetic flux density times with the cross-sectional area. So A must be cross-sectional area, yeah, cannot be area only, yeah. So this means that magnetic flux, what is magnetic flux? Magnetic flux is the magnetic field line, the line. So magnetic flux is equal to BA, where the SI unit will be Tesla or Weber per meter square. So you see, Tesla, now we have a very famous vehicle, okay, starting using around the world. So there is a Tesla vehicle. So Tesla vehicle actually is fully electronic, fully electric car compared to the technology, the present technology. We are using a hybrid car. Hybrid means that the combination of petrol and also the electric. Tesla will be fully electric car. Engine car will be the old technology, or now we still are using the engine car. This means fully using petrol. Now we notice that when the magnetic field are parallel to the surface, so we use the formula magnetic flux equal to BA and times with cos delta. Why cos delta? Because sometimes the angle are not the angle of the surface, and the B and A, they will not be parallel. So if there are some angle difference, will be like that. So that means no matter how, B and A must be parallel. So we cos the angle. We times with cos delta. That means that we change the, what's that, the surface, the area, the cross-sectional area, the normal of the cross-sectional area, the surface, we cos delta to become is parallel to the surface. So how about 60 degrees? So flux density will be less, and 90 degrees, totally none, because the magnetic field not pass through the surface of the coin. Next. So now, if there is a coil only with the angle, so we use BA cos delta will be the flux linkage. Magnetic flux linkage or magnetic flux only is equal to BA cos delta. What happened, as we know that we learned before in Form 5 physics, in the chapter of electromagnetism, the subtopic of the induction, the factor that produce the strength of the electromagnetic force, one of the factor will be the number of turns. So what happened if we add the coin? We add coin, continue increase the coin. That means that we notice that the magnetic flux linkage keep on increase. So that means that one loop experience a magnetic flux linkage equal to BA cos delta. For n loop placed in a magnetic field, the net flux experienced by the n loops is the algebraic sum of the magnetic flux of each loop. That means sum of the loops. So that means we need to times on how how many turns or how many loops. So as a result, magnetic flux linkage is equal to NBA cos delta. Now, let's observe. The Waiver Step that magnetic flux is equal to BA cos delta. For the unit for B is Tesla T. Therefore, the unit A is for meter square, and the unit for the magnetic flux is Tesla times with the meter square. So Tesla meter square. 1 Tesla meter square will be equal to 1 Weber. Okay, one line only. One line only, this means that 1 Gauss is equal to 1 flux line per cm square. According to the Tesla, Tesla defined that how many lines in 1 cm square. How many magnetic flux? So 1 Tesla, if the unit of 1 Tesla means that it will be 10,000 flux line per cm square. Okay, 1 Tesla. Okay, 1 Tesla equal to 1 Weber per meter square, or equal to 10,000 okay, Weber per cm square. So this means that easiest 1 Tesla equal to 1 Weber per 1 meter square. So 1 Tesla means that in the area, the cross-sectional area of 1 cm square, there will be 10,000 flux line, 10,000 magnetic flux line. That is the density of the magnetic field. As a conclusion, as a summary, we can say that magnetic flux consists of imaginary lines called flux lines, which start at a magnetic north pole and end at a magnetic south pole. Magnetic flux is given by expression where magnetic flux equal to BA cos delta. B is the magnetic field in the unit of Tesla. A is the cross-sectional area, which meter square, and angle is the delta is the angle between the magnetic field B and the lines perpendicular to the cross-sectional area of A. Magnetic flux linkage is defined as the algebraic sum of magnetic flux of each loops in the magnetic field. If n is the number of loops or coils of wire, then magnetic flux linkage is given by the expression magnetic flux linkage equal to NBA cos delta. And finally, the unit for the magnetic flux is Tesla square meter. So Tesla times meter square. Or we said that it is 1 Weber. So 1 Tesla is equal to 1 Weber per meter square. Let's look at the next slide. The slide shows that a magnet, a magnet is ready to move into a solenoid, where the solenoid is connected to a meter, to a milliwatt meter, to make sure the magnitude of the induced EMF. Ladies and gentlemen, let's observe if we move in and move up. So how is the direction? The direction are opposite, right? So move in, move up. What will happen if we move slow? Observe the minimum and maximum. Maximum left side, maximum right side. So it will be -20 and 20, right? +20. If the magnet move with faster speed, so we notice that left side with -40 milliwatt, right side with 40 milliwatt. So this shows that the magnitude of the EMF is directly proportional to the speed of the magnet in the solenoid. According to Faraday's finding, the more rapidly the magnetic field change. What is meant by magnetic field change? Magnetic field change here, we can set that the change are, how is the change? This means that the change can be the, magnetic flux has been cut, or the magnetic field strength increase or decrease. Increase of the magnetic flux or decrease of the magnetic flux. The type of change number 3 will be change of the direction of the magnetic flux. That means change of the magnetic pole. This means that magnetic field change refers to the 3 types of change. This EMF is not simply proportional to the rate of change of magnetic field B, but rather to the rate of change of magnetic flux passing through the circuit or loops area A. Any change in the magnetic environment of a coil of wire will cause a voltage. That means that there is an EMF there. So induced EMF. So to be induced in the coil. Induced means that produced. Voltage will be generated no matter how the change is produced. The change could be produced by changing the magnetic field strength, moving a magnet towards or away from the coil, moving the coil into or out of the magnetic field, or rotating the coil relative to the magnet. So any motion, any change of the magnetic flux will cause the EMF induced. So this is the basis of the physics called electromagnetic induction. Ladies and gentlemen, with the definition of flux, the result of Faraday's investigate can be defined. EMF induced in a coil is equal to the rate of change of the magnetic flux through the coil. So EMF is equal to negative change of the magnetic flux over dt, change of the time. If the coil contains n turns, the EMF induced in each turns add up together way the expression for the n turns is EMF equal to negative n the change of the magnetic flux over dt. So from here, since the change of the magnetic flux is equal to BA cos delta, that means that EMF is equal to N d over dt BA cos delta. This will be the formula used to determine the EMF. Ladies and gentlemen, why we use negative? Because according to the Faraday's law, which we learned in Form 5 syllabus, the direction of the induced EMF or induced current will be in opposite direction. Still remember, Faraday's law said that the direction of the induced current is always opposite the effect of the magnet to produce it. So, next slide show that voltage generated by varying B with the T. One way in which voltage can be generated is by varying the magnetic field B with time. In this case, a bar magnet is moving such that the magnetic field through the coin changes at a rate of 0.4 Tesla per second. The coin with 9 turns has an area of 0.03 meters squared. The variation of B with T is dB over dt. dB over dt now is 0.4 Tesla per second. The cross-sectional area of the coin will be 0.03 meters squared. When the magnet is moved in, a current is generated. Okay, so we want to find out the EMF induced. So the formula for induced EMF become negative N d dt BA. So negative NA dB over dt. Negative N. So how many turns? Times is 9 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 turns times with 0.03 times with the dB dt, that's 0.4. We get that the induced EMF will be negative 0.0048 watt. Okay, so which equal to 10.8. That's wrong. Should be, okay, so please make a change here. So it should be, let me count, is it 10.8 or 4.8? 9 times. Okay, so it should be 0.0108. 0.010 watt. So that means this is wrong, yeah? So negative 0.048 watt is wrong. It should be negative 0.0108. Sorry for the mistake. So the final answer will be correct. So it's negative 10.8 milliwatt. This 10.8 milliwatt is correct. Ladies and gentlemen, why negative? Because the direction of the induced EMF is opposite the direction of the magnetic effect to produce it. Okay. Now, next slide. When a series of coin or a solenoid, repeated coin with n number, n is equal to 20 turns, we move in a uniform magnetic field. Now the magnetic field is go into the plane, go into the paper. So let's observe what happened. Ladies and gentlemen, we notice that if the coin move with a speed of 0.8 ms -1, how the coin will cut the magnetic flux. How the coin will cut the magnetic flux. So how is it the EMF induced? The dimension of the coin is 0.2 meter times 0.2 meter. This will be the area. The formula of EMF generate is equal to negative NB dA dt. Okay, so by using the formula dA over dt, change of the area divided by time will be equal to V times with the L. Okay, V times with the L. So that means that dA over dt will be equal to VL, the speed, times with the length, which is 90 degrees to the speed, yeah, the direction. So EMF will be equal to negative 20 times with B 1.2 times with V times L, where V times L will be dA over dt. Then we get it will be negative 3.84 watt. Negative show the direction is opposite. So magnitude is 3.84 watt. Now we observe, we go to the next slide.